Kinematics is another crucial important topic, but I have always emphasized that kinematics, dynamics, electricity, current and nuclear physics, these are very scoring chapters. I'm putting the first question. The graph shows the variation with mass of the weight of objects on a particular planet. What is the value of the acceleration of free fall on the planet? So it's weight upon mass.
So it will be the gradient.
Yes. I'm taking this position 3.2 upon 2.
It is 1.6.
A skydiver falls vertically from a helicopter and reaches constant velocity. This is something very important, and it means that resultant force is equal to 0. It means acceleration is equal to 0. The graph shows the variation with time of the speed of the skydiver. The skydiver falls vertically from a helicopter, and then he says the graph shows the variation with time of the distance fallen by the skydiver. So this is a famous sketch, and I hope you remember this sketch. So velocity is increasing at a decreasing rate. At the point velocity becomes terminal, it means constant. And when you come to distance time graph, its gradient is velocity. So it should be a straight line. I'm cancelling B because B is the copy of the given graph, which is not possible. Velocity should be increasing at a decreasing rate.
So distance should also be increasing at a decreasing rate.
No, distance time graph is the gradient of a distance time graph is velocity. Here the gradient is velocity. And if you come in this sketch,
Okay, then there's its distance, acceleration, velocity over time.
in this graph, the options given are velocity distance time graphs.
So we have to see a decreasing gradient gradually.
We need a graph which is showing a straight line later, but initially it should be showing increasing gradient. Velocity is increasing now. Velocity is increasing.
So it should bend towards the t or the d axis.
No, increasing gradient, getting steeper. Okay, I think
so
the part of acceleration is giving a confusion. I remove this part. Now you should see the first part of the graph is showing that velocity is
increasing. So it's either A or C, which shows that the velocity is increasing.
A or C, they're very close. This is wrong because it's keep on decreasing.
But A and C are almost like identical. They're almost the same, except
But
for
we
the
have to see
starting.
carefully. There is a small difference. In C, the graph slides on x-axis and then take off. While in A, the graph immediately takes off. It's a case of paratrooper. It's very important thing, skydiver. When skydivers jump, they do not immediately begins to come down. There is a delay. If you see this one,
The air resistance we also have to keep in mind.
yes, air resistance also, okay, there is a delay. While in case of A, there is no delay. Skydivers do not begin to travel immediately. So both the sketches are very close. So now select which one is better.
So C,
Yes, good. C is the option. The momentum of a car of mass m increases from P1 to P2. What is the increase in the kinetic energy of the car? I have re-derived this formula. Now I have two options here. Either I go for this or what's the formula for momentum? Momentum is equal to mass into velocity.
so there should not be any square in it, like half PV.
No, I'm trying to make two equations, and because in MCQ, you always have to see the options, because in every option mass is there. So I made two equations, and you can tell me which one would be better. Now this is the working.
So is it A?
Closest is looking to be A. A
The
rock on
last
the
is still a
yes.
bit confusing, like about the rearrangement of the formula.
That's always a challenge, but there is no other way. There is no way other than keep on doing them, because you have to see the solution options and then you have to select the formula, because technically there is no formula or no one-way method to remember what to do. It always depends upon the options.
So
A
first
rock,
we took out that the momentum is equal to half PV from the kinetic energy
huh,
formula.
we
And
have option. Na? We can get the formula for V. V is equal to P upon M. So I selected the second formula because the first formula was giving a problem to me because it was not having mass.
so the
A rock,
velocities formula was rearranged to give like the final
yes.
formula.
A rock on the surface of Mars is projected vertically upward with an initial speed of 9.4. The rock rises to a height of 12 meters above the surface. Assume there is no atmosphere on Mars.
So we can use an equation of motion for this question.
We have to first make an idea here. What formula suits here? Should I take 2s?
Yes, the 2s is equal to v squared minus u squared. So the final velocity will be 0 as it is reaching a max.
Yes.
It is coming 3.68.
Sorry, how much?
3.68 meters per second squared.
A projectile is launched at an angle to the horizontal at time t is equal to 0. It travels over horizontal ground as shown, which air resistance is negligible. Which graph best shows the variation with the speed of the projectile from when it is launched to when it lands on the ground. Speed comes back now. You know that the speed of the launch speed is equal to strike speed.
This is for the horizontal motion
Hmm?
or both the vertical, because in horizontal
The
it's showing.
resultant, you're right, vertical velocity decreases to zero and comes back. But the overall velocity is the same at launch position and strike position. So launch and strike speed is the same. When it is going upward, velocity will be decreasing. And I hope you remember that at the highest point,
The velocity will be zero.
no, this is at projectile. Na? Projectile is not zero. Projectile vertical component is zero, but whole velocity is not zero.
The horizontal component will remain.
Ha.
And the horizontal will remain like the same throughout.
But in this question, horizontal or vertical is not the question. The question is overall velocity, resultant velocity. So now I have made the diagram. You can select now that which graph actually suits us here. Remember that resultant velocity never becomes zero. Resultant velocity never becomes zero during a projectile motion.
So B and D are wrong. It shows that they become zero.
Uh,
And I think the A is for the horizontal component because it is showing like constant the whole time.
this is also wrong because he's talking about, you're right, it's for the resultant velocity. It's for looking for vertical horizontal component. A tennis ball falls freely. Free fall means no air resistance. From the top of a tall building, which graph best represents the variation with time t of the distance s fallen?
So eventually it will reach like a terminal velocity,
No,
but there is no resistance.
there is no air resistance. So I'm collecting the information I have. It's a distance time graph. So the gradient is speed. All the graphs are distance time. So the gradient is a speed.
So if it is falling from a constant acceleration of g, won't like the velocity also be like increasing at a constant rate?
Velocity is increasing at a constant rate.
Okay. So B and D can be wrong because they're showing a decrease in the velocity.
D is showing velocity decrease. I have marked all the sketches translation. This is how I always tell the student to solve sketches, that do not look on one sketch or do not keep on looking them. Try to write your work and see which is the best, because sketches are very cleverly designed.
So I think A matches with this as it is the only one showing that the velocity keeps on increasing.
Just excuse me for a minute. The velocity of an object changes with time t as shown. The velocity of an object changes with time t as shown. It's a velocity time graph. So I have, as usual, marked the notes. I have marked the notes on it. And you have to see that the gradient here,
It will be the displacement.
here the gradient is acceleration, and here the gradient in the options sketches, gradient is equal to velocity. So this is another good example of tricky sketches, tricky questions, that now you have velocity decreasing, and this is the first sketch.
In the A part, the after the velocity becomes zero, it is increasing because it is going in the opposite direction.
Velocity is increasing because if you are going to zero, it's a logical thing. If you are reaching to zero, if you are reaching to zero, you have to, if you are reaching to zero, you are logically decreasing. And from zero onward, velocity is increasing.
Okay, after zero, it will always increase.
Ah.
So I think option A matches with the above graph.
Now you have to see.
So is it A?
I'm also checking all the options that I think you are right. A is the best option because no other option is matching. Right. A is the right answer.
Is C showing an increase in velocity or a decrease? Because it is moving away from
You're
the
right.
S.
You're right. C, the gradient is decreasing. A stone is projected vertically upwards from the ground at an initial speed of 15 meter per second. Air resistance is negligible. What is the maximum height reached by the stone?
So final velocity will be zero and the acceleration will be positive G, negative G as it is going upwards.
Right.
The S is coming as 11.4 meters.
11.4.
Yes. So will it be B if we take it to like two significant?
I think the closest is B. A ball of mass m is thrown up to height h in air with an initial velocity v. Air resistance is negligible. what is the total work done by the gravitational force on the ball during its flight from P to Q?
So the work done will be equal to the energy.
Work done for gravity is always gravitational potential energy.
So
Work done.
gravitational force is the the mgh, the gravitational potential energy.
So you have to carefully see it's going upward and coming back to the same position.
So will it be zero as it is force into distance in the direction of the force?
No,
This
the
is
point is that when it is going upward, there is a gain in gravitational potential, and when it is coming downward, potential energy is related with height only. So there is an upward motion, and then there is a downward motion. Because when it travels upward and then it comes down, the overall change is the same. It means it goes up and comes down. So there is no air resistance. So the work done would be equal to 0. A stone is projected horizontally in a vacuum and moves along the path shown. It's a projectile case.
so the air resistance will be zero as it is in a vacuum.
Yes, air resistance is definitely 0 because it's traveling in a vacuum. Air resistance is 0, and he says horizontal. So initially, Vx is there, Vy is 0. X is a point on this path, xv and xh are vertical and horizontal line represent respectively through x. Xt is the tangent to the path along which directions do forces act on the stone at x.
So will we only count the horizontal velocity as it said horizontally?
No, he's talking about position X. I have highlighted the initial position, but the question is on position X. There is no air resistance, so there is nothing which is opposing the horizontal component. And you know, when something is coming down, which force is getting it down?
The gravitational, the weight.
Yes. Gravitational. He's not asking for the force. There is no horizontal force and there is a gravitational force in XV direction.
So there's no force either on the XH.
Sorry, can you repeat?
So will there be no force on XH either?
Yes, because there is no air resistance now.
So XV will be the answer only.
Yes.
And why won't there be a force on XT?
XV is the gravity, na? It's going downward. So when something is going downward, it's
No, on
simple that it, huh?
XT, the horizontal which it says XT.
He's asking XV and XH. So there is no force on XH because there is no air resistance. XV is vertical and there is a vertical force, which is the gravitational force.
Okay.
So we have done questions related to kinematics, and